we are going to have to make a logical quantum leap in order to put right what once went wrong and to finally bring Einstein's theory of everything home. Ironically, it was Albert's lack of imagination that stumped him in his attempts to understand quantum mechanics and relate it to relativity. It's doubly ironic because the key to solving this conundrum is in fixing his incorrect assumptions within relativity, which Albert believed he already had, thus making it the very last place he would have ever thought to look. His error is, of course, the assumption that the universe is static. He underestimated how this one assumption shaped all of relativity from the very beginning. Now, I want to be clear. I'm not saying Albert Einstein was wrong. In fact, his problem was that he was so close to being right that no one could tell that he wasn't. This led everyone to believe that it was quantum mechanics that needed to be fixed. In fact, the errors in relativity causes everyone to misinterpret quantum mechanics and thus made it unexplainable, since trying to explain quantum mechanics in a three-dimensional universe is impossible. It's only with the true understanding of a universe as a four-dimensional space that you can even begin to understand how to think about quantum mechanics. Therefore, I assert that quantum mechanics is the logical outcome of point particles governed by the fundamental forces in a four-dimensional universe where the fourth dimension is distorted from our perspective due to the relativistic effects caused by our motion through the fourth dimension at the speed of causality. This is the only way to think of quantum mechanics and maintain causality and locality when combining it with relativity. To show how this happens, we must first start with the simple photon, because the photon is a point particle. Therefore, it can exist in only one dimension, and it does not have a position in any of the other dimensions until it's shifted to that dimension via an interaction with something within that dimension. This interaction causes the photon to disassociate from the temporal dimension and enter the dimension that the interaction happened in. But because the temporal dimension is distorted from our perspective, the place the photon enters the new dimension is governed by a probability of interaction between the two dimensions described by quantum mechanics. When the photon enters this dimension, it is no longer distorted from our perspective. Thus, the photon takes on an undistorted point particle appearance. This is what has been called the collapse of the waveform. The reason the photon is always emitted into the temporal dimension is because this is the dimension the electron moves from one orbital to the next lower energy orbital, and when it does this, it gives off the energy required for this move as a photon. The photon is always moving at the speed of causality into the temporal dimension, and since we are in motion at the speed of causality in the opposite direction through that same dimension, this means that the photon will be stationary relative to the temporal dimension. This happens for the same reason that a soccer ball shot at 40 miles an hour out the back of a pickup truck that is moving at 40 miles an hour down the road causes the soccer ball to be stationary relative to the road. When the photon is in the temporal dimension, it will be distorted from our perspective due to the relativistic effects. The shape of the distortion of this dimension and the photon will be spherical, just like Einstein's bubble paradox, where Albert was disturbed by the suggestion that the surface of the bubble could collapse instantaneously, because he thought this violated the laws of locality. But in reality, quantum mechanics doesn't violate them at all, because the entirety of the surface of the bubble is a single point in the fourth dimension distorted from our perspective. One can be excused from thinking of this as an illusion, like the illusion we see at the bottom of a pool. However, the image of the pool's floor is distorted by the water altering the path light takes to our eyes, whereas the spherical distortion of the temporal dimension is the distortion of the fundamental nature of how we relate to the temporal dimension. Therefore, if the photon is at that point in the temporal dimension, it can also be anywhere that that spherical shell of the temporal dimension intersects with any of the other three physical dimensions. This means that the photon for all intents and purposes, is, in that moment, a spherical shell, which acts like the wave probability we think of in quantum mechanics. This way of seeing the fourth dimension makes it easier to understand how two photons can remain entangled with each other, even though, from our perspective, they are seemingly vast distances from one another, because from their perspective, they are right next to one another, and thus communication between each other is instantaneous for that reason. This has been an overview of how the four-dimensional universe solves quantum mechanics from my book, Temporal Quantum Relativity. And if you want to find out more about how four-dimensional space gives us wave-particle duality and causes the wave function of the electron, you might want to check it out. The links will be in the description below. But don't worry, when I wrote Temporal Quantum Relativity, I left out any equations and instead put in many drawings to help get these difficult ideas across to more people. Thanks for watching. And now, in the next video, I will describe the experiment that we will need in order to test temporal quantum relativity against reality.